Problem number 7. A welded steel cylindrical drum made of 10 mm plate has an internal diameter of 1.2 meters. Compute the change in diameter that would be caused by an internal pressure of 1.5 megapascal. Assume that the Poisson's ratio is 0.3 and the modulus of elasticity is 200 megapascal. This is the cylindrical drum. And the thickness of this drum here is equal to 10 mm, and we have the internal diameter of 1.2 meter. So kung maglalagay tayo ng axis, this axis here is the y-axis and this is the x-axis. If we are going to cut this along the x-axis, so magkakaroon tayo ng cross-section, and this cross-section here, so as you remember, ito ay merong mga forces along the y-axis, diba? So meaning, and from the derivation, what we compute here is the longitudinal stress. So in this case, this is equal to the stress in y direction. And if we are going to cut this along y, and so dito we have the horizontal forces, diba? And what we compute here from our derivation of formula, and we have here the tangential stress, and of course this is the stress in the x direction. Now the stress in y is, which is equal to the longitudinal stress. Now if we are going to review the formula, we have the same formula, diba, for the longitudinal and tangential stress. So since we have the same look of the formula ng longitudinal stress and the tangential stress, we know that stress is equal to PD over T, and we have here PD over T. Now we will be choosing between 2 and 4. So this is for longitudinal and this is for tangential. From the word longitudinal, we have here 2 and 4. 4 is longer than 2, so we go with the longitudinal, and that's 4. And of course 2 here. So computing the value of the longitudinal stress, we have the longitudinal stress is equal to PD over 4T. So this is equal to the P given in the problem, that is equal to 1.5 megapascal. So we have here 1.5 megapascal. The diameter given in the problem is 1.2 meter, and 1.2 is 1,200 mm over 4 multiplied by the thickness. The thickness given in the problem is 10 mm. So we have here 10 mm. So computing for the longitudinal stress, that would give us 1.5 times 1,200 over 40, and that would give us 45 megapascal. So we have here 45 megapascal. Now for the tangential stress, that is sigma x. This is equal to tangential stress. So we have here tangential stress is equal to PD over 2T, and tangential stress is equal to P, which is 1.5 megapascal, multiplied with the diameter 1200 mm over 2 times 10 mm. So we have here the stress in X, and we know that the tangential stress is twice that of the longitudinal stress, and that would give us 90 megapascal. So since we are interested in the change in diameter, so we are going to compute for the strain along the x-axis, since along the x-axis we can find the diameter. So we have strain in x is equal to stress x over modulus of elasticity minus Poisson's ratio. So sabi ko kanina, if this is x, of course, since biaxial ito, this is stress in y over e. Kung gagawin natin siyang mas kamukha, kung gagawin natin siyang kamukha ng formula natin sa triaxial stress, then we have this form here. And since we know that in the triaxial stress, nadagdagan lang tayo ng isang axis, and if this is x, no, so dito magkakaroon tayo ng plus sigma z. So since we know that the strain in x is the change in diameter over the original diameter, right? So we have here change in diameter over the original diameter, and i-replace natin ito. So magkakaroon tayo dito ng change in diameter over the original diameter is equal to 1 over e multiplied by the stress in x, Poisson's ratio multiplied by stress in y. So substituting the value, we have the change in diameter over the original diameter, which is 1200 mm, is equal to 1 over the modulus of elasticity. Since the modulus of elasticity is expressed in gigapascal, if we are going to review our units, no, so dito sa number line, we have here pascal, this is kilopascal, megapascal, and we have here gigapascal. So this is times 10 to the 3 times 10 to the 6 times 10 to the 9. Since this is in gigapascal, meaning from giga ay ililipat natin siya to mega. So 9 minus 6 is 3. And we would have here 200 times 10 to the 3 megapascal. Yung 200 gigapascal ay 200 times 10 to the 3 megapascal. Now, the stress in X, since we already computed for that, that is equal to 90 megapascal. So we have here 90 megapascal minus the Poisson's ratio equal to 0.3, and the stress in Y, that is the longitudinal stress, 45 megapascal. So computing for the change in diameter using the calculator, we have here the unknown diameter over 1200. This is equal to 1 over 200 exponent of 3 times 90 minus 0.3 times 45. Shift, solve equals, and we have here 0.459 mm. And our answer here is 0.459 mm. This is our answer.